A pleasant morning to each and every one of you. I'm Alita Angelita Ring, and I'm one of the reporters for today's topic, the geometric sequence. In today's video, we will be tackling the introduction to the concept of geometric sequence, the rules of geometric sequence, the formula to be used, and how to identify the geometric sequence. Before we start indulging ourselves with the whole of geometric sequence, let us first know what are the contents of the report. So first, we will be tackling the introduction to the concept of geometric sequence. Second, we will be going with the geometric sequence formula that will be followed with the rules of geometric sequence. And lastly, we will be identifying geometric sequence. What is a geometric sequence? Geometric sequence was discovered by German mathematician Johann Carl Friedrich Gauss, born in Germany 1777 when he was only 10 years old. Why is it called geometric sequence? The name geometric series or sequence indicates each term is a geometric mean of its two neighboring terms, similar to how the name arithmetic series indicates each term is the arithmetic mean of its two neighboring terms. A numerical sequence with a common ratio between succeeding words is referred to as a geometric sequence or geometric progression. Each term following the first is found by multiplying the preceding one by a fixed, non-zero value known as the common ratio. Each word in a geometric series is equal to the one before it times the common factor, which is a constant multiplier that is never zero. Geometric sequences can either have an unlimited number of terms or a fixed number of terms. For example, the sequence 2, 6, 18, 48, and so on is a geometric progression with common ratio of 3. Similarly, 10, 5, 20, 2.5, 1.25, and so on is a geometric sequence with common ratio of 1 half. It is important to know that a progression and a series is different. Progression is a sequence, whereas a series is a sum. Before we proceed to the formula, I would like to add something about why we need to learn geometric sequence and also to sum up what we have learned about geometric sequence in my part. Okay. Why do we need to learn geometric sequence? We learn about this because we encounter geometric sequences in real life, and sometimes we need a formula to help us find a particular number in our sequence. We define our geometric sequence as a series of numbers, where each number is the previous number multiplied by a certain constant. Thus, we've learned that a geometric sequence is a sequence of numbers where each number is found by multiplying the previous number by a constant. To determine if a sequence of numbers is a geometric sequence, we divide each number by the previous number. The geometric sequence formula. What you see in the bottom of this slide is the general form of the sequence. It shows the definition of geometric sequence just like what was mentioned in the earlier slide. In this general form, you can see A and R. A represents the start term or the first term, whereas R is the common ratio. Above the general form is the formula we will be using. We have A sub n is equal to A sub 1 multiplied to the quantity of r raised to the power of n minus 1. A sub n is our nth term, A sub 1 is our first term, r is the common ratio, and n is the term position or the position of the term we are looking for.
Good day to everyone watching. I am Ruth Daniela Basco and I will be the one to tackle about the rules of geometric sequence. As what mentioned by the first reporter, the geometric sequence goes from one term to the next by multiplying or dividing by the same value. The number multiplied or divided at each stage of the sequence is called the common ratio. In my part in this video, I will be showing you how to determine the nth rule of a geometric sequence. To do that, we need a formula that's gonna help us do just that. So, to look for the nth term, we will use the rule which is A sub n equals A sub 1 multiplied to the quantity of r raised to the power of n minus 1. We already know that a sub n is the term we're looking for, or the nth term. A sub 1 is the first term, r is the common ratio, and n is the nth term. We use r raised to the power of n minus 1 because r raised to the power of 0 is the first term. Now, I have two examples and I want you to solve it with me. First example, 6, 18, 54, blank, 486, 1458, and so on. Look for the ninth term. First, we have to get the common ratio, which is the r in our rule or formula. To get the common ratio, all we have to do is divide the first and second term in our sequence. In this sequence, we have 18 and 6. Thus, r is equal to 18 over 6 equals 3. So our common ratio is 3. Now let's move on to the next step, the substituting of the values in order for us to use the formula. In this example, we are looking for the ninth term. Therefore, the n in a sub n is 9, as well as the n in r raised to the power of n minus 1. Our value in a sub 1 is 6, and the common ratio is 3, as what we have solved earlier. Now we have a sub 9 is equal to 6 multiplied to the quantity of 3 raised to the power of 9 minus 1. It becomes 6 multiplied to the quantity of 3 raised to the power of 8, since 9 minus 1 is 8. Next, we will be calculating 3 raised to the power of 8. That is equal to 6,561. 6 multiplied to the quantity of 6,561 is 39,366. Therefore, our ninth term is 39,366. Also, since our fourth term is unknown, what we can do is to multiply 54 by 3. 54 times 3 is 162, so that is our fourth term. Now on to our second example. 20, blank, 288.8, 1097.44, 4170.272, and so on. This time, we are looking for the second term. To get the common ratio, let's divide two consecutive terms. 1097.44 divided by 288.8, it equals to 3.8. So 3.8 is the common ratio. Now let's substitute the values to complete the formula. A sub n will be a sub 2. A sub 1 will be 20. The common ratio is 3.8 to the power of 2 minus 1. Now that we have the formula, we can now solve for the second term. Subtract 2 minus 1, so a sub 2 equals 20 multiplied to 3.8. 20 times 3.8 is 76. So 76 is the second term. We can also multiply the first term, which is 20, to 3.8, and we'll still arrive with the answer 76.
Now we're on to the identifying of geometric sequence. The two main types of sequences are geometric and arithmetic. Understanding what kind of sequence is being dealt with is essential. Knowing the fundamental traits of a sequence or series is necessary for differentiating between the two primary types. To differentiate the two, arithmetic is when each term in an arithmetic series is equal to the one before it plus a certain number. For example, 5, 10, 15, 20, and so on. Each term in the sequence equals the terms before it with 5 added on. While geometric, in contrast, a geometric sequence is one where each term equals the one before it multiplied by a certain value. An example would be 3, 6, 12, 24, 48, and so on. Each term is equal to the prior one multiplied by 2. For the next segment of our video, we are given the opportunity to dig deeper and understand more of the geometric sequence, particularly the identifying of geometric sequence to be given to us by one of our reporter, Mr. Aldrich Budios.
Good day, everyone. I'm Aldrich, and we will go deeper, have a deep understanding about this topic, and identify the geometric sequences. Geometric sequence is a sequence in which we can get the succeeding term by multiplying the previous term to the fixed number called the common ratio. The common ratio, or R, can be determined by dividing any term in the sequence by the term that precedes it. As you can see here in the right portion of the presentation, there is an example. Identify the common ratio and the next two terms in this sequence, 1, 2, 4, and 8. Consider 1 is the A1, 2 is the A2, 4 is the A3, 8 is the A4, and so on. Just divide the second term by the first term. 2 divided by 1 equals 2. The common ratio is 2. To find the next terms, we multiply 8 by 2. 8 times 2 is 16. Then multiply it again by 2. 16 times 2 is 32. The sequence is 1, 2, 4, 8, 16, and 32. We have also here the second example, 2,500, 500, and 100. Just do the same process to get a common ratio. 500 divided by 2,500 equals 1 over 5. Then multiply 100 by 1 over 5 or divide by 5. We get 20 and 4 as the next two terms. The sequence is 2,500, 500, 100, 20, and 4. The sequence is geometric if there is the common ratio. First example, state whether this sequence is geometric or not. The sequence is 5, 20, 80, and 320. To check if there is the common ratio, just give its common ratio. 20 divided by 5 is 4, 80 divided by 20 is 4, and 320 divided by 80 is 4. As you can see here, they have the same answer. The sequence has a common ratio of 4, and it is a geometric sequence. 7 square root of 2, 5 square root of 2, 3 square root of 2, and square root of 2. 5 square root of 2 divided by 7 square root of 2 is 5 over 7. We just have to cancel the square root of 2. Then divide the third term by the second term. We get 3 over 5. They have the different answer. The sequence doesn't have a common ratio. Therefore, it is not a geometric sequence. 10 over 3, 10 over 9, 10 over 27, and 10 over 81. 10 over 9 divided by 10 over 3, we get 1 over 3. 10 over 27 divided by 10 over 9 is 1 over 3. 10 over 81 divided by 10 over 27 is 1 over 3. They have the same answer, and therefore it is a geometric sequence. The nth term of the geometric sequence is given by a sub n is equals to a sub 1 times r to the power of n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio and should not be equal to 0, and n is the term position. Let's try to answer this example. What is the 10th term of the geometric sequence 8, 4, 2, and 1? The common ratio is 4 divided by 8, or 1 half. The first term is 8 and the n is 10. Just substitute the values using the formula. We have 8 times 1 half raised to 10 minus 1, which is 9. Then evaluate 1 half raised to 9. So we have 8 times 1 over 512. Multiply, we have 8 over 512, and simplify. The final answer is 1 over 64. Next, we have to find the 8th term of the sequence 4, 8, and 16. The common ratio is 2, first term is 4, and the n is 8. We have 4 times 2 raised to 8 minus 1. 8 minus 1 is 7. Then evaluate 2 raised to 7. We get 128. 4 times 128 is 512. And that is the final answer. The third term of the geometric sequence is 1 over 5. And the sixth term is 1 over 625. Write the first 6 terms of the sequence. We will use 1 over 5 as the first term and 1 over 625 as the nth term. There are 4 terms from third term to the sixth term. We have 1 over 625 equals 1 over 5 times r raised to 4 minus 1. 4 minus 1 is 3. Then divide both sides by 1 over 5. we get 1 over 125 equals r cubed. Take the cube root of both sides and we get 1 over 5 as the common ratio. Now we have to divide the third term, which is 1 over 5 by 1 over 5. 1 is the second term. 1 divided by 1 over 5 is 5. 5 is the first term. The first 6 terms of the sequence are 5, 1, 1 over 5, 1 over 25, 1 over 125, and 1 over 625. That's all on identifying geometric sequences. Once again, this is Aldrich. Thank you and have a nice day.